All right, this is the review for the quiz tomorrow. Hopefully you guys have done the majority of the review, and this is just a final check for you guys to confirm your answers. So let's go ahead and get started. Number one, it says to perform the indicated operation and state restrictions. All right, so just to remind you that this is multiplication right here. So when you're multiplying, you do not need a common denominator. Right? So you don't need to get a common denominator. All you're going to be doing is multiplying. So that's number one. Number two, you do need to factor first and then reduce common factors. And this is for both multiplication or division. All right, this is the same steps for both. So you don't need a common denominator. You do need to factor first, then reduce the common factors, and then the third step will be to simplify. All right, so the first one, the numerator and the denominator, it's going to factor as we want something that multiplies to -6 but adds to -5. And so those numbers are -6 and +1. So this one is going to factor as x minus 6 and x plus 1. All right, again, whenever you're factoring, if the leading coefficient is 1, you can just do the x method, okay? The second one down here, I need something that multiplies to -12 and adds to -36. Or sorry, to +36. So that would be, I'm sorry, I have those backwards. Something that multiplies to 36 and adds to -12, which would be -6 and -6. And so this is going to factor as x minus 6 times x minus 6. All right, and then we have times. This one is a difference of squares. Or you could say I need something that multiplies to -36 and adds to 0, which is -6 and +6. Also, difference of squares, a squared minus b squared, always factors as a plus b, a minus b. And so in this case, we have x squared minus 36. So a is x and b is 6. So this factors as x plus 6 and x minus 6. So x plus 6, x minus 6. And then finally, in the denominator here, we have x squared minus 19, x minus 20. So I need something that multiplies to -20 and adds to -19, which is -20 and +1. So this is x minus 20, x plus 1. All right, now we're going to check for common factors, right? So we factor first, reduce common factors. So common factors can be top to bottom, or they can be diagonally. One needs to be in the numerator and the other in the denominator. So for example, these two, they're common factors, they can cancel. Also these two, they're common factors, they can cancel. And finally, these two, let me do that in a darker color. These two are common factors, so they can cancel. So all that's left is x plus 6 over x minus 20. All right, so that's number one. Number two, all right, the steps for adding and subtracting is, when you're adding or subtracting, is to find the common denominator, the least common denominator. And to do that, you factor, identify common factors. So factor the denominator, I should say. Identify the common factors. Identify missing factors from each fraction. And then we're going to multiply. Step 2 is to multiply each term by the missing factors. And then step 3 is to write in one fraction and simplify. All right, so we're going to factor this denominator and this denominator. So I have 1 over x squared plus x minus 2 minus 2 over x squared minus 1. Okay, so this one is going to factor as, we need something that multiplies to -2 and adds to 1. That would be 2 and -1. So this will factor as x plus 2, x minus 1. And this one again is a difference of squares, just like up here. X squared minus 1 is going to factor as x plus 1, x minus 1. Right? A is x and b is 1. And so this is x plus 1 and x minus 1. All right, so now that I've factored the denominators, now I'm identifying common factors. So they do have a common factor right here. So that needs to be in my denominator. And then the missing factors, identifying missing factors from each fraction. This fraction is missing the x plus 1, and this fraction is missing the x plus 2. So again, I have to have my LCD has to have the common factor, x minus 1. It also has to have this factor, x plus 1, and this factor, x plus 2. So that is my LCD. So I'm going to multiply this fraction by x plus 1, and whatever you do to the denominator, you must do to the numerator. And this one I'll multiply by x plus 2. And so before I do that, I'm going to go ahead and make sure that I take care of this subtraction sign. I'm going to put plus and put my minus right there. All right, I would distribute through, but 1 times 1, x plus 1 is just x plus 1 over the LCD, plus I have a -2 that needs to distribute through. That's -2x minus 4 over the LCD. All right, my next step is now that I've multiplied each factor, write in one fraction and simplify. So I'm going to write this in one fraction. So I've got x plus 1 minus 2x minus 4 over the LCD. And then combine like terms, which is simplifying. I've got an x and a -2x, that's -x, and that's minus 3 over my LCD, which was x minus 1, x plus 1, x plus 2. Sometimes they'll factor out that negative. They could rewrite this as negative and then x plus 3. But generally we don't do that. We can just leave it the way it was, but either one of these would be correct. Okay, and so that was number 2. So number 2 is x, -x minus 3 over x plus 1, x minus 1, x plus 2. All right, number 3, it has both of these happening in it. So we've got division happening. So we don't need to get a common denominator because of that, but we also have addition and subtraction happening. And so we're going to have to get a common denominator. Okay, so I'm going to go ahead and do that problem over on this paper so that we have more room. 1 plus 1 over x, and then x minus x over x minus 1. All right, so the first thing I'm going to do is get a common denominator. The common denominator here, I'll put a 1 in the denominator, and the common denominator would be x for the numerator here. Excuse me. All right, So that means that, or 1x, right, 1 times x, but I can multiply this by 1, it won't change anything. I need to multiply this one by x over x. Anything I do to the denominator, I must do to the numerator. And so in the numerator here, I get x over x, and then plus 1 over x. And then remember, now that I've got my common denominator, now I write it in one fraction and simplify. So this is x plus 1 over x. All right, in the denominator, I'm going to do the same thing, get a common denominator. The common denominator is x minus 1. So I'll multiply both the numerator and the denominator by x minus 1. This one, I can multiply by a 1, but it won't change anything. All right, so I would have, don't forget to distribute through, x squared minus x over x minus 1, and then minus x over x minus 1. I'm going to go ahead and change this to plus and put my minus right there so I don't forget. And now I have I can combine like terms in the numerator. That's negative x and a negative x, that's negative 2x. And then over x minus 1. All right, so I've taken care of the addition and subtraction. Now I need to take care of the division. So this division, I'm going to rewrite it. This is x plus 1 over x divided by x squared minus 2x over x minus 1. All right, before I move on, I have forgotten to check restrictions on all of these. So I'm going to go back and check restrictions. So on the first one, right, our restrictions right here, where x cannot equal 6, negative 6, 20, and negative 1. So x cannot equal 6, negative 6, 20, and negative 1. The restrictions here are that x cannot equal negative 2, positive 1, and negative 1. So again, x cannot equal 2, negative 1, or positive 1. Sorry, negative 2, negative 1, or positive 1. All right, and the reason that I remember to do that is because right here I'm going to have to check for restrictions before I before I multiply by the reciprocal. So I take my denominators, x cannot equal 0, x cannot equal 1, and now I'm going to multiply by the reciprocal. So I'm going to flip this one upside down. I get x plus 1 over x times x minus 1 over, I'm going to go ahead and factor this, take out the common factor of x. And the reason that I did that is so that it's easier for me to find my restriction. So right here, I get another restriction. X can't equal 0, which I already have. X cannot equal 2. All right. Now, if there's anything in common, I can reduce it, any common factors, but there aren't. So this is going to be x plus 1, x minus 1, over, I'm going to write that as x squared, and then x minus 2. And my restrictions, again, are x cannot equal 0, 1, or 2. All right, so number 3, we should have x plus 1, x minus 1, over x squared, and then x minus 2. And x cannot equal 0, 1, or 2. All right, before we move on, I just want to remind you that you could have written this as, and they'll take either answer. They could also write this as x squared minus 1 over x squared and then x minus 2. You cannot cancel those x squareds out. This is separated with addition or subtraction, so it's not a factor. All right, let's move on to number 4. All right, so number 4 is probably the culmination of the entire unit. So we need to, using this equation, find all of these items: wholes, vertical asymptotes, horizontal asymptotes, x and y intercepts, domain range, and then we're going to have to graph it. All right, so to find wholes or vertical asymptotes of the graph, okay, wholes and vertical asymptotes come from the denominator. Solutions, or x-intercepts, come from the numerator. All right, so the first thing I'm going to do is try to find any holes or vertical asymptotes. Remember, those happen where the denominator cannot equal 0. So to find that, I'm going to factor and then set each factor equal to 0 and solve. All right, so I'm factoring the denominator. This is I need something that multiplies to 12 and adds to -7. And so the two numbers that multiply to 12 and add to -7 are -4 and -3. So this factors as x minus 4, x minus 3. While I'm at it, I'm going to go ahead and factor the numerator since I'm rewriting it anyway. So to factor this numerator, remember it's a difference of squares. So that factors is x plus 3, x minus 3. All right, so now I'm going to take each of these and set them equal to 0. X x cannot equal 4, x cannot equal 3. Now these are my vertical asymptotes or holes. And the difference is vertical asymptotes only make the denominator 0. Holes make both the numerator and denominator 0. Okay, so you can see 3. If I plug in 3 in the numerator, I'm going to get a 0 right here. So 3 is a hole in the graph. But if I plug in 4 into the numerator, I will not get 0. So 4 is a vertical asymptote. All right, so we're going to go ahead and put that on here. So we've got a hole at x equals 3 and an asymptote at x equals 4. All right. Now, horizontal asymptotes are a little different. Horizontal asymptotes of the graph, there's 3 rules. You look at the degree of the numerator versus the degree of denominator. All right, if the degrees are equal, so if they're equal, then you're going to look at the leading coefficients, which are 1s. So if they're equal, you look at leading coefficients, the ratio of the leading coefficients is the vertical asymptote, or sorry, the horizontal asymptote of the graph. Okay, if the degree of the numerator is smaller than the degree of the denominator, the constant term, which is almost always x equals 0, or sorry, y equals 0, is the horizontal asymptote. And then finally, if the degree of the numerator is larger than the degree of the denominator, there's none. Okay, so we're going to look at what case we have. And we actually have case number 1 right here, that they're equal, right? The degrees are both degree 2. So we're going to look at those leading coefficients again, which is a 1 and a 1. And it's going to be the line y equals 1 over 1, which is 1. That is your horizontal asymptote. Y equals 1. All right, x and y intercepts. So to find the x-intercepts, you let y equal 0 and solve. So that's what we're going to do. We're going to let y equal 0, which is y is the same thing as f of x. Y equals x squared minus 9 over x squared minus 7x plus 12. Now, again, I'm going to point out that solutions come from the numerator, wholes and vertical asymptotes come from the denominator. So I actually don't even need to look at the denominator. I've already found those points. I'm only going to use the numerator. And I'm going to set it equal to 0. And when I do that, I can factor or I can solve by square rooting. I'm going to factor it. Set each factor equal to 0. And my two solutions are at x equals, my two potential solutions are at x equals -3 and x equals +3. All right, but what happened was that this x equals 3, right, is actually an extraneous solution because it is a hole in the graph. So this one is not a real solution. This is my only solution at x equals -3. So x equals -3 is the x-intercept, or you could say the point -3, 0. To find the y-intercept, you let x equal 0. So use the numerator and then let y equal 0. Well, to find the y-intercept, you use the entire function and you let x equal 0. And so I've got y equals 0 squared minus 9 over 0 squared minus 7 times 0 plus 12. So this is just -9 over 12, which is -3 over 4, which is -0.75. Oops, -0.75. And so my y-intercept is at y equals -0.75, or you could say at 0, -0.75. All right, the domain and the range. You can graph it to see that, but also the domain is going to be all the values of x. Well, the values of x are going to stop at 2 places. So this graph is going to go to the left forever. It's going to stop at 3 because there's a hole. It's going to pick right up again and go to 4 because there's an asymptote there. And then it's going to go to infinity. And then up and down, it's going to go downward forever. It's going to go all the way up to y equals 1. It's going to stop, and it's going to pick right back up again and go on forever. So I already know my domain. My domain is going to be from -infinity up to 3, union. It's going to pick up at 3 again and go to 4. Union, it's going to pick up at 4 and go to infinity. And again, these two values, right, my wholes and vertical asymptotes, actually tell me my domain. My range is given by the horizontal asymptote of the graph, which is going to be from -infinity up to 1. It's going to stop. Union, it's going to pick right back up again at 1 and go to infinity. All right, now to graph this guy, I'm only going to graph a few points. I'm going to plug in points into my equation and solve. So I'm going to make a little table of values for x and y. I already know some important values. I'm going to try -2, -1, 0, 1, 2, 3, 4, 5, 6. I'll plug in these values and see what I get. Now, there's some of them I already know. For example, when x equals 0, right, y was -0.75. Also, I know at 3, the graph is undefined. And I know at 4, the graph is undefined. Also, I know what happens at -3. It crosses through and you get 0. I forgot to put the -3 on the graph, but anyway. All right, so that was one of my solution points. Now you're going to plug in values. So we're going to plug in some values into our equation, which is right here. I'll plug in -2. Y equals -2 squared minus 9 over -2 squared minus 7 times -2 plus 12. And that gives me 4 minus 9, which is -5, over, that's 4 plus 14 plus 12. And 4 plus 14 is 18. Negative 5 over 18 plus 12 is 30. So this is negative 1 over 6. And then I'm going to use my calculator to turn that into a decimal value. So negative 1 divided by 6 is negative 0.167 repeating. So negative 0.167 repeating. All right, and then you do this over and over and over and over again. All right, when you do that, you have to be very careful watching your signs. And then to graph, we're going to go ahead and put on all of these special features. So I know the graph crosses at negative 3, 0, right there. I also know at 0, negative 0.75, which is right here, there's a point. And I know at 3, there's a hole. And then at 4, the graph is undefined. So I'm going to sketch a line at 4. There's my vertical asymptote of the graph. I also know there's a horizontal asymptote at 1. So here's my vertical asymptote. Here's my x-intercept and my y-intercept. And then my horizontal asymptote is at 1. After you've filled in your table, what you'll see is that this graph is doing something like this. And you can confirm it using Desmos or some other graphing tool. But on this quiz tomorrow, you will have to be able to sketch this by hand. So you need to plug in values and sketch your graph. All right, I'm going to pause the video here. We'll take it on in the next video for the second side.